Good day, students. How have you been? We're going to continue in our theory lessons looking at ICT applications. And today we're going to focus on measurement applications. In today's class, we will be describing a range of measurement applications for scientific experiments, weather stations. We'll also differentiate between analog and digital data and explain why we need to convert, why we need conversions between them. Also, we will be describing the use of microprocessors in computers in a range of applications like pollution monitoring, intensive care units in hospitals, and etc. And the last thing we'll be doing is discuss the advantages and disadvantages using computers for measurement offer rather than using humans. Now, how do measurement applications work? We have sensors. What do the sensors do? They send data to the computer where the data is processed. So they measure properties and they send it to data. Properties such as temperature, wind speed, pressure. The computer simply reviews the data from the sensors by comparing it to data stored in memory and updates its files or gives a warning if the values are outside of the given parameters. Okay, and I've mentioned some of the examples where we use measurement. Now we're going to look at analog and digital data. What is a digital data? Digital data is a discrete, fixed value used by computers. So when you hear discrete data, we're talking about fixed values. Whereas analog data signals are continuous values that vary smoothly. For instance, temperature varies smoothly. Temperature is not constant. It moves down, up and down, up and down. But what the discrete, a computer cannot understand that kind of data. It needs to be able to measure that at this exact microsecond, this was the data. So that's why we say discrete, fixed value data. All right? And these are some of the examples of data that we measure. Length, weight, temperature. So because of that, we need a device called the analog to digital converter. It helps convert the analog data from the sensors into digital data. And also sometimes, we're going to be talking about that in control processes, we may need what I call the digital to analog converter, DAC, to help the computer communicate with actuators, some output devices, but we're not going to dwell on that today. So let's have an example. For instance, you want to measure the pollution in a river. What do? You measure you monitor the oxygen levels in the river. One, sensors that read data are placed in various positions. The data from the sensor is converted into digital data using an ADC. The computer stores the received data. Now, the oxygen levels and the acidity levels that the sensors that you have placed in and measuring are compared to the historical data stored in the memory. That means you have some data already in the memory. One of two things will happen. Either the data is transferred into a CD or DVD or to a memory stick, stored away for later analysis and is connected into a mobile phone, or it's connected to a mobile phone, and transmitted to a control center where we can say it's the monitoring station. So that's how pollution is measured or monitored. What about in intensive care units? Most of the times in movies you see things attached to people, sensors attached to people. What are those sensors actually reading? They are reading the pulse rate, the temperature, the blood pressure, the respiration. So how does this monitoring or measurement occur? The data from the sensors, from these key vital signs, is converted, like we said the other time, into ADC, because it's converted into digital data using the ADC. The data is then stored in the computer memory. It's compared with values stored in its memory. Now, the results are also output on a screen in form of graphs or digital readouts. An alarm is activated if any of the data is outside acceptable parameters. How do we even know the acceptable parameters? That means beforehand there will have been preset values that the microprocessor will be checking. So let's say the preset value is for temperature is between 34 and let's say 38. Once it drops below 34, then an alarm goes off. Or once it goes beyond 38, an alarm goes on. And that's how all the other key vitals are measured. So this is just a summary. Sensors measure physical quantities. You have weather stations, you have greenhouse, you have patient's vital signs. And don't forget, input devices called sensors feed data into the computer. The computer processes the data. As a result of the processes, the computer can either output the data or just store it in memory. Thank you for listening and viewing this with patience. I'll be seeing you on the Google Classroom. If you have any questions regarding today's class, then we'll talk about it on the stream.